example 6. This is on 9-2, day 3. And I believe it's called example 1 on your paper. It should be called example 6. Okay, find an equation in the form y equals ax squared plus bx plus c as the graph passes through the points whose coordinates are 1, 4, negative 1, 6, and 2, 9. Now, these problems are pretty simple. It's under the category of what's called curve fitting. Okay, we're trying to create a quadratic function, so it's a parabola function, right? We want to figure out the values of a, b, and c that make these 3 points come out for a parabola. So a parabola structure is that right there, y equals ax squared plus bx plus c. The variables are going to be a, b, and c. X and y are known quantities. If x, y is 1, 4, that means if I use this specific structure right here, y is changing to a 4, x is changing to a 1. So 1 times a plus 1 times b plus c. So the ordered pair 1, 4 creates the equation a plus b plus c equals 4 based on this structure in that ordered pair. The second ordered pair is negative 1, 6. This is x, this is y, this is my structure. Y is changing into the number 6. X is changing to negative 1. Negative 1 squared is positive 1 times a is a. Negative 1 times b is going to be minus b, and then plus c. And then finally, 2, 9 is another ordered pair, x, y. That's supposed to fit into this structure. Y is equal to 9. X is equal to 2. 2 squared is 4 times a is 4a. 2 times b is going to be plus 2b, and then plus c. So we create our system of equations here. Our goal is to find the values of a, b, and c. We have 3 ordered pairs, so we got 3 equations, 3 unknowns. We have the ability now to solve it. Okay. In the event that this is a workable problem, we'll be able to get an answer. If it's an impossible problem, which can happen also, these were lined up in a straight line. You can't make a parabola out of a straight line, right? So you create a system that's impossible. It would end up being an empty set situation. So looking at it, I can get rid of a, b, or c. What do you want to get rid of? B. Perfect. I want to get rid of b. So if I want to get rid of b, I'm going to add these 2 equations together, ready to go. I like the letters on the left. So a plus a is 2a. C plus c is 2c. 6 plus 4 is 10. And then the other set, I would probably combine these 2, doubling this one in the process. So 2a plus 4a is 6a. Negative 2b plus 2b cancels. 2c plus c is 3c. And 12 plus 9 is 21. And it's ready to go at that point. I would probably reduce the top to a plus c equals 5. And reduce the bottom down to 2a plus c is equal to 7. Everything in the black divides by 2, everything in the red divides by 3. Changing signs at the top would be the easiest route, in my opinion. So if I just make that minus a minus c equals minus 5. Combine the 2 equations. 2a minus 1a is equal to a, c minus c cancels, 7 minus 5 is 2. If I take the black equation, a, which is 2, plus c, we don't know yet, is equal to 5. That means c has to equal 3. If I take the blue equation over here, a plus b plus c, a, which is 2, plus b, we don't know yet, plus c, which is 3, is equal to 4. That means b plus 5 equals 4. That means b is equal to negative 1. Okay, so it's just a system of 3 equations like we've been doing already now in this section. Now it asks us to find the equation of that form, right? So we've got a structure the equation fits into. We just figured out what a, b, and c equal. So they want the answer written just like this, changing a, b, and c into the numbers we figured out. So y is equal to 2x squared minus 1x plus 3. So make sure that you are writing your answer in the curve fitting problems in the structure they're asking you to write it. It usually is just going to match this, just changing the values of the letters we found into what the numerical values are.